Alright, in an experiment, the number of a certain type of bacteria is given by n of t is equal to 100 plus 32t squared minus t to the power 4, where t is the time, sorry about that, in days since the experiment began, and t is greater than 0 but less than 5. Find the intervals of increase and decrease of the number of bacteria. Alright, so what we want to do here is to find intervals of increase and decrease. Let's find critical numbers. So to do that, we need to first find the derivative function, n prime of t, which is basically I'm going to do the derivative with respect to dt of 100 plus 32t squared minus t to the power 4. Okay, sorry about that, guys. Let me just clean this up a little bit. Okay, there you go. And in this case, you get the derivative of 100, which is 0. 32 times 2 is 64t minus 4t cubed. Okay, so this is n prime of t. And now what you want to do is you want to find the critical number. So you're going to let n prime of t, the first derivative function, equal 0. So when I do that, I get 4t cubed, negative 4t cubed plus 64t is equal to 0. Now you can notice that there is a 4t as the greatest common factor. I'm going to factor out the negative 4t, and you basically will get t squared minus 16, okay, excuse me, is equal to 0. And you can actually notice that this portion here, it looks like a squared minus b squared, so you can factor this as negative 4t, t plus 4, t minus 4 is equal to 0. Okay, let's just kind of clean that up there. My penmanship just isn't too great today, is it? Alright, so this is basically what the factor form of the derivative function looks like, and you can see that the values of t will equal 0, negative 4, and positive 4 to let the first derivative function equal 0. So this is basically your this is basically your critical numbers, right? So once you have your critical numbers, you want to find intervals of increase and decrease, right? So to do that, what I'm going to do is I'm going to create a number line to figure out the intervals, right? So this is 0, this is negative 4, okay, this is positive 4, I'm not drawing this to scale, this is positive infinity, this is negative infinity. I'm going to highlight some of the intervals. Now we noted before that we're always going to have one more interval than the number of critical numbers. Okay, so one of your intervals here is negative infinity and negative 4. Okay, and we're not going to include the negative 4 and the positive 4 and the 0, right? I should have circled this as well. So these are your critical numbers. We're not going to include those because that's when the derivative function is equal to 0, and that indicates the maximum or minimum point. Okay, the other interval here is negative 4 and 0. Okay, then we have another interval from 0 and 4, and we also have an interval from 4 and positive infinity. Okay, using these 4 intervals, what I'm going to do is design a table of intervals to show you guys where the intervals of increase and decrease occur. Okay, so this is just a way to kind of organize our data. Okay, so I'm just going to do that out here. Okay, so we have these 3 factors. Okay, so we have negative 4t, we have t plus 4, and we basically have t minus 4, and together this collectively makes our derivative function n prime of t. And I'm just going to put the intervals up here that we looked at. So one of the intervals is negative infinity and negative 4, right? We also had negative 4 and 0. Okay, we also had 0 and 4, and we also had 4 and positive infinity. Okay, so this is 4 and positive infinity. Okay, so now what we want to do here is look at each interval. So between negative infinity and negative 4, I'm going to let x equal negative 5. So if I let x equal negative 5, negative 4 times negative 5, this is positive. Okay, negative 5 plus 4 is negative 1. Negative 5 minus 4 is negative 9. And then collectively, this is going to give us a positive, right? So this is an interval of increase. Whoops, let me just, so this is an interval of increase wherever you see a positive sign. So this is an interval of increase here. Okay. Between negative 4 and 0, I'm going to let x equal negative 2. Negative 4 times negative 2 is positive. Negative 2 plus 4, positive. negative 2 minus 4 negative, so this is negative. So this is actually decreasing. So this is an interval of decrease. Okay, so that's an interval of decrease, an interval of increase. Between 0 and 4, I'm going to say x is equal to 2. And then you get negative here, positive, 2 minus 4 negative. You get a positive here, so this is sloping upwards, so this is an interval of increase. Okay, now between the next interval, 4 and positive infinity, I'm going to let x equal 6. So you get negative, positive, positive, and that's going to give you a negative. So this actually indicates an interval of decrease. Okay, and in this case, our interval of increases collectively are basically x belongs to negative infinity and negative 4, union 0 and 4, and our interval of decrease collectively is basically x belongs to negative 4 and 0, union 4 and positive infinity. Okay, so those are your interval increases and decreases.